Okay, so today we're going to be doing 7.5. This kind of takes everything we've done up to this point and puts it together and makes us graph it. So the first one is in intercept form. So to find our x-intercepts, because it's in intercept form, that's where I'm going to begin. To find your x-intercepts, you set each binomial equal to 0. So when I solve them, add 1 to both sides. We're left with x equals positive 1. So one x-intercept is at 1, 0. And then the second intercept, we subtract 3 on both sides to solve that. And we're left with x equals negative 3. So your other x-intercept is negative 3, 0. So now, in order to find the vertex, the axis of symmetry, and the y-intercept, we have to get this into standard form and vertex form. So to get this into standard form, we multiply the two binomials. So I'm going to draw my area model in this space. And I have x minus 1 is one binomial, and x plus 3 is the other. So when you multiply this out, x times x is x squared. Negative 1 times x is negative 1x. X times 3 is a positive 3x. And negative 1 times 3 is negative 3. So standard form for this quadratic equation is x squared, combine your like terms, plus 2x minus 3. So now label all of the parts of that equation. So a equals 1, b equals 2, and c equals negative 3. C is the same as your y-intercept, so I can go ahead and write that over under y-intercept. So 0, negative 3. So now I still have to find my vertex. To find the vertex, you do the x equals negative b over 2a. So we have negative b is 2 over 2 times a is 1. So negative times 2 is a negative 2. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. So now we take that x value and we plug it back into our standard form. So we have x squared plus 2 times x minus 3. And our x value is negative 1. So when we plug that in, we're left with y equals negative 4. So now we have the two values that make up your vertex. X is negative 1 and y is negative 4. So your vertex is at negative 1, negative 4. So the axis of symmetry. Remember, the axis of symmetry cuts through your vertex and it separates your parabola into two equal halves. The equation for the axis of symmetry is x equals negative 1 because it's going to pass through the x value of your vertex. So when we put this on the graph, we have a vertex of negative 1, negative 4. We have an x-intercept of 1 and another of negative 3, so negative 3 and 1. We have a y-intercept of negative 3. So now we can draw our parabola. So the next one is very similar. It is also in intercept form. So we can jump down and place both binomials equal to 0 and solve for our x-intercept. So we have x minus 2 equals 0 and x minus 6 equals 0. So to solve that first one, we have plus 2, and x equals 2. So our x-intercept is 2, 0. And on the other, we plus 6. We're left with x equals 6. So your other x-intercept is 6, 0. So now we have a leading coefficient, that 2, that factor 2 in the front that we have to take care of next. So we're going to go ahead and distribute it to that first binomial because that's what it's touching. And that leaves us with 2x minus 4 and x minus 6. That 2 is not touching the second binomial, so we do not distribute it to that second binomial. So now we can put it in the area model and factor that out. So we have 2x minus 4, x minus 6. So when we do that, we have 2x times x, which is 2x squared. We have negative 4 times x, which is negative 4x. We have 2x times negative 6, which is negative 12x, and negative 4 times negative 6, which is a positive 24. So now we can rewrite. We have 2x squared, combine like terms, minus 16x plus 24. So now we can label all the parts. We know a equals 2, b equals negative 16, and c equals 24. Because c equals 24, your y-intercept is 0, 24, and we still have to find the vertex. So to find your vertex, we do the negative b over 2a. So x value of your vertex is negative, b is negative 16, over 2 times a is 2. So a negative multiplied by a negative is a positive 16. 2 times 2 is 4. 16 divided by 4 is 4. So the x value is 4. So we plug it back in to find the y value. So we have 2x squared minus 16x plus 24. Our x value we just found is 4. So when we plug this back in, we get y equals negative 8. So our vertex is at 4, negative 8. The axis of symmetry cuts through the x value of your vertex, so it is x equals 4. Now, because we can't go to 24 on your axes, I made my y-axis go up by 3s. So when we look at our graph, I have 3 here on mine to indicate that those values are increasing by 3s, and I have a 1 on here to indicate that those are going by 1s. So 1, 2, 3, and that one's 3, 6, 9, etc. So to graph this, we have a y-intercept of 24. We have x-intercepts 2 and 6. We have a vertex that's 4, negative 8. So remember our y-axis is going by 3, so we go to 4 and then we go 3, 6, approximately 8. And then we can draw our parabola. So I'm going to leave the third one for you guys to do, and we're going to go ahead and explore the rest. So flip on to the back of this paper or the front of the next paper, and we have this one. So this one is in standard form. So I'm going to go ahead and write that underneath it just as a reminder. So to find the vertex, remember it's negative b over 2a. That's where we begin this. So we have a value is half, b value is negative 3, and your c value is 1. So our y-intercept is 0, 1. You can go ahead and plot that if you wanted. So to find the x value, negative b, so we have negative negative 3 over 2 times a, and a was half. So a negative times a negative makes a positive. Half of 2 is 1. So your x value for your vertex is 3. So when you plug it back into that equation, we end up with 1/2 x is 3 minus 3 times x is 3 plus 1, which gives us negative 5.5. Which makes our axis of symmetry at x equals 3. Now we go back to our equation and we see that this has a 1/2 as the a value, which means it's a horizontal stretch by a scale factor of 1/2. Also, that a value, that 1/2 is positive, which means the direction of our graph is opens up. You can use your calculator to make a table of values. That's what I did. So we've got -2, 9, -1, 4.5, 0, 1, 1, 1.5, -1.5. 2 is -3, 3 is -5.5, and 4 is -3. So when you go to graph this, we can't do that -2, 9, so I'm going to skip it. -1, 4.5. I already have my y-intercept. 1, -1.5. 2 is -3. 3 is -5.5, so I'm just going to put it slightly below the graph. And 4 is -3. So now we can draw our parabola. Okay, so our next one. This one is in vertex form. So remember, if you need to write it, feel free to write it. So we have y equals ax minus h squared plus b. And your vertex is, plus k. And your vertex is hk. So the number in the h position is that 3. And the k is -1. Which means your axis of symmetry is x equals 3. The direction of this, because your a value is negative, which means it's going to open down. Your a value is 4, so that's a vertical stretch with a scale factor of 4. And then you have to put it in standard form in order to get the y-intercept. So as a reminder for going from vertex to standard form, you have to take care of your exponent first. So we have -4 x minus 3 squared minus 1. So the first thing we want to take care of is this. So when you do your box, x minus 3 times x minus 3, we're left with x squared minus 3x minus 3x and a positive 9. So we're left with x squared, combine like terms, minus 6x plus 9. And make sure you put it back into that formula. So I'm going to distribute that -4, which leaves me with -4x squared plus 24x minus 36. And then bring down my -1. So when I combine like terms, one last time, I have -4x squared plus 24x minus 37, which means my y-intercept is -37. So 0, -37. Now again, you can use your calculator to make a table of values here and then graph what you can. Lastly, go to the bottom section. This is a review of all of the transformations happening from an equation. Run through it, then check your answers on Canvas later.